Yeah, good evening, everyone. So, Johnny Camps, let's start off. Why people are still late? Yeah. Regarding this testing, right? I kept a sample paper online right now. You can just go and see like how it feels like, how to give the test. Later on, you can do that end of the class. Right? It is just 10 questions. There will be no marking or anything. It is just for you to, get a feel of how does the paper look like, what is the pattern and everything. Okay, I think one, two, Aditya, Niranjan, Palaksh, Vidyut, Rehan, Adrit, Abhinav, you guys have registered so far. Remaining people are yet to register. So once you register the site, right, if you open it, you will see an access. You'll see two papers. One paper will be sample paper, which is online right now. 10 questions you can just try so that you get a feel of, okay, how does the screen look like and all, because suddenly it will be a surprise. Another paper will be basic maths and vectors, which will be online on Tuesday evening. So that will be written there, like, coming up soon. Garga. So do have a look at that. If someone is confused with the site or something, we have time till Tuesday. So something happens, at least you can tell me.
Sir,
So give that sample ka test. Bina.
so the paper, the MCQs, are they single correct or are they mix of single and multi correct?
I gave you the paper pattern, right? It will be single choice on. Multi-correct, it will be written on the top, don't worry.
Okay.
On top of the question, it will be mentioned. But these are all single choice questions only. I think one integer is there, but all are single. 24 single choice and one integer got mixed up. Okay. And who is missing? Mayura is missing. It is there. Yasha Swastika is there. Okay, so let's start off. So do give that sample test later on, right? And see if there's anything you couldn't log in, which problem hua, anything issues, you let me know. Leave me a message. I'll see you. I'll sort it out. If you see, I give you the timetable for the next 1 month. There are 4 tests. So 2 tests and then a break, and then we have 2 tests. So, okay. So we'll be starting off with calculus today. So last thing we finished with vectors. Now calculus, right, is quite important, especially in terms of advancement. Most of the problems, even in advanced level, what you observe is there is a bit of calculus involved. Now, if you see the level of calculus that we use, actually is quite less compared to maths. But like I always keep telling you, maths and physics are not same. Problem is not exactly calculus, but how do you apply calculus? That becomes a thing. Today is just an introduction thing, but still I'll show you some models. But next class, I think we will do the actual applications. So let's start it off. So we'll be doing pretty basic stuff. We'll not go into the derivations of how the formulas came and all that. Max people will take care. What we are more interested is applications. The first thing is a function. What is this function? So when you write y is equal to f of x, we keep writing like this. So the meaning of this thing is the quantity y is a function, depends function of x. That is the meaning of y is equal to f of x. That is how we pronounce it. So we pronounce this as y is equal to f of x. That's how we pronounce. What do you mean with this exactly? Example, you have seen this, you just don't know. If you take a volume of a sphere, volume as function of a radius is 4 by 3 pi r cube. Actually, now we should have written like this. V of r is 4 by 3 pi r cube. But what we do is we simply write volume is equal to 4 by 3 pi r cube. You're getting it? It is the same thing. We should write S of t is equal to ut plus half at square. You know this equation, S is ut plus half at square. So it is like a full name, okay? It is like, for example, if you look at my name, right? It is like Arun Kumar Sana. No one keeps on calling me, hey, Arun Kumar Sana, come here. People just call Arun, come here. So the same way, right? Every time instead of saying that displacement as function of time t is ut plus half at square, we simply say S is ut plus half at square. Got it? This is important because we keep on hearing this kind of terms later on. So if I write v of t, meaning velocity as function of time t, suppose if I write a of x, acceleration as function of position, so it is not really a new thing. You have seen this, just that we never called it with a full name before. Okay? Have a look at this.
So technically every formula is basically a function, right?
It's like every formula, right, has like a surname. We just don't use the surname, right? It's kind of like that. So how do we get this example? If I take few more, let's say if I say y is equal to f of x is equal to x cube. Any doubts on the first page? Clear, right? Rona, can you keep your cam on? Yeah. So what is the meaning of this? So if I say f of 1, this becomes 1 cube. If I say f of 3, meaning x का place में just keep 3 cube. Getting it? So it just substitute the values there. Suppose if I say f of x is x square and g of x is 2x plus 1. And if I say f of g of 2, what is the meaning of this? First find g of 2. That is 2 into 2 plus 1, which is 5. So basically you are asking me f of 5, which is 5 square and 25. Got this thing? So this idea is important. You can keep a function inside a function. So you can have a nested function. You know, in coding we call it nested loops. Ever heard that term? You have a for loop inside, you keep one more for loop type. So it's like a function inside a function. You could have gone even something like f of g of h of x. You could have gone 3 layers also. But so that idea is important. So this term called function, you just need to have a basic idea. So whenever someone uses the word f of x, it is nothing big. It is telling you that y is depending as a function of x. Clear? No. I hope all are clear with this thing. Easy, basic stuff. Next thing, differentiation. Now in calculus, you have two parts. The differentiation and integration. In max, they will teach you almost for 2.5 months this entire thing. And they'll teach you at a much higher level. Like I said, but what we are interested is the mainly applications. So some other things we are not interested in how these things are derived. So let's see what is this exactly differentiation and how do we actually use it in physics? Let's say consider 2 points. A x1 y1, b x2 y2. So if I take 2 points here, A and B, And if I join a line like this, so this is delta y, which is y2 minus y1. This is delta x, which is x2 minus x1. This angle is theta. So we can write tan theta is y2 minus y1 by x2 minus x1. This we can also write it as slope is equal to delta y by delta x. This is the slope of what? This is the slope of line AB. Clear? And here theta is the angle made by the line with the positive x-axis. This I'm sure you learned in school.
Yes, sir.
Great. So we do know the meaning of slope, as delta y by delta x, which is y2 minus y1 by x2 minus x1. Great. Now what happens if I try to apply the same formula for a curve? Any doubts on this page? All clear? Now, if you try to apply the same formula on a curve, something happens. So on the curve, imagine you take 2 points here. Let's call it A and let's call it B. Right? Let's call this thing as x comma y, and let's call this thing as x plus delta x comma y plus delta y. So basically you increased by x and increased by y. Now, if I try to use the same formula, see what happens. So if I use the formula slope, which is delta y by delta x, what did you get actually? This is slope of the line AB. And this has no relation to the curve. You just randomly took 2 points on a curve and you found the slope of it. It has no meaning actually. And this has no relation to the curve. So actually that same formula which we used for a line, if I use for a curve, it suddenly becomes useless. Right? Then you say, okay, fine, it is useless. What if I make delta x smaller? If you make delta x smaller, then see what will happen to the graph. So when you say I'm making delta x smaller, you're actually bringing A and B closer. Yeah, so it came closer, but yeah, still doesn't make sense. This still has no significance. It has still no meaning. You're getting what you're doing? So we took a slope and we are pushing it. You're bringing them closer and closer. So there, it has no meaning there. Let 1 second, who is missing? Why you guys are not coming? Okay. So great. So we brought them closer and nothing interesting happened. Now, if you do something even better, what if I bring them so close? If delta x tends to 0. So this is how we pronounce this. Delta x tends to 0. Meaning the points A and B have almost become same. Now suddenly something happens to that line. You bring the 2 points so close to each other. Now if you try to draw, that line actually becomes a tangent. the line AB becomes a tangent to the curve. See, now the line AB has some meaning to the curve. I hope you're getting the logic there. You're getting the story there? So if you look at the story again, see, look at the story there. The slope formula delta y by delta x which you use is valid. It works for a line. But when you use it for a curve and you take any 2 points, it is suddenly useless. There's no information on it. If you bring them closer, useless. But if you bring them so close, you keep it almost, the delta x tends to 0. Suddenly that line AB, which becomes a tangent to the curve. So we can write this thing as slope of the tangent to the curve. Now see, delta y by delta x has no meaning. So we have to write limit delta x tends to 0. So when the delta x is very small, the quantity delta y by delta x becomes the slope. I get the meaning of this mathematically, how we are putting it. So this is a mathematical way of putting the statement. When the delta x is very small, the quantity delta y by delta x becomes the slope of a tangent to the curve. If I don't use this word limit, now this has useless quantity. But the moment I add that limit, suddenly it becomes an important quantity. There. So from a straight line, we brought it to a curve. Do have a look at this. Try to understand how we are bringing it, like, and how we're deriving that part. Clear with this? Anyone has a doubt on this? Anyone? All clear with this? Arjun, Niranjan, Abhinav, clear, na? Maulika?
So, one doubt.
Huh.
So the slope of the tangent is actually not equal to the slope of the curve, but it's just good enough for the.
No,
side.
meaning, see, for a curve, the slope is different at different points.
That's what, yeah.
Yeah, so it is pretty close to it. Clear? Ritu, got this? Maulika, clear, na? Nee, na, formula is not the same. We will see, na, it will become something else slowly. This word has meaning to it. Okay? So we write like this thing. So limit delta x tends to 0. So this quantity delta y by delta x is slope of the tangent to the curve. Now we are lazy people, right? We don't want to write this every time, limit and all that. So we come up with something better. So we simply call this thing, this quantity, limit delta x tends to 0, delta y by delta x as dy by dx. So the delta thing becomes dy. So basically delta meaning big change, d meaning very small change. End of the day, physically both means the same thing. But the moment you use the word dy by dx, it is understood you're talking about a very small quantities. Now be careful here, don't cancel this d and this d. This whole quantity, right, d by dx is called a differential operator. That whole thing is a symbol actually. The d and d are not digits, not alphabets. And what does this do? A differential operator, right? It compares y with x. Whatever quantity you're taking, it compares with x here. So we call this quantity, dy dx. See, just like, plus, minus, division, into, right, are arithmetic operators. So same way dy dx is a differential operator. You should not cancel the d and d. Be careful. It's like, if I have 2 plus 3 into 5 plus 4, if I take out plus common, I get 23 into 54. Does this make sense? You don't do such things. So the same way, if you cancel d and d, I'll also feel that way. You'll feel weird. So instead of using all this limit and all this stuff, we use something called D. So the moment you use the word D, we know we are talking about very small changes. Okay? So the mathematical form of this, so dy by dx is simply, so let's say on a curve, y is equal to f of x. So we are taking two small points here, A and B. It's a very small distance here, h. Don't worry too much about this. The slope is given by limit delta x tends to 0 is given by f of x plus h. So that f y is the f of y coordinate is this. So this point ka y coordinate is f of x plus h, and this coordinate is f of x, and this coordinate is x, and this coordinate is x plus h. Basically, you're finding for the slope of this point here. So the slope ka formula is given by f of x plus h by f of x by x plus h minus h. Basically, I'm using y2 minus y1 by x2 minus x1 ka formula. So for any differentiation, right, we use this formula to figure it out.
Sir,
Right.
so over here, h is delta x, right?
H is a delta. Yeah, sorry. H is delta x. H is a delta x. H is the difference in height, or because we are using x, na, delta x will look confusing. So that h is the difference between them. So here to here is h. H is very small. Okay, what does this mean exactly? So let me show you how this works actually. So any differentiation, any formula, this is what we use. Example. Let's say we use y is equal to x square, and you want to find the differential of this. This is written as dy by dx. Like I said, max people will teach you all this. I'll just want to show you one. So limit h tends to 0. We are using f of x plus h. So this is actually y is equal to f of x is equal to x square. That is the meaning of this. The y is depending as a function of x, which is equal to x square. So this function becomes x plus h whole square minus x square by x plus h minus x. So this will be limit h tends to 0. If I expand that in the numerator, we get x square plus 2xh plus h square minus x square. This will cancel, and denominator get h. The limit h tends to 0, h will cancel. We get 2x plus h. Since h is very, very small, you can neglect it. This becomes almost equal to 2x. That means if you differentiate the quantity x square, we get 2x. What is the physical meaning of that? The meaning of that is, so if you have a parabola here, y is equal to x square. If you take this point here, let's say x is equal to 1. At this point, if you draw a tangent, this is theta. Just now we proved the slope, which is dy by dx for x square is 2x. That means tan theta is equal to 2x. So this is the slope of the tangent at a particular x coordinate. So here x is equal to 1. Are you getting the meaning of this? So at a particular point x is equal to 1, the tangent made by the slope of the tangent is tan theta is equal to 2. Suppose if you have taken a line like this, x is equal to, let's say, -3. Then the angle made by this thing, let's call it alpha. So the slope of the green line will be tan alpha, which is 2 into x, where x is -3. Are you getting this? So by using differentiation, right, you can find the slope of any tangent on this curve using the slope curve formula. Have a look at this. Now, technically speaking, right, all this is not needed for us. So, but I thought, instead of directly giving you the formula, better you have some understanding where it is coming from. Maths people will do all this. So basically, this is the primary rule of finding a differential. They will use this to find for everything. We are not interested. I just wanted to show at least one. Okay? So we will directly jump into the formulas there. So see now, we derived it, right? Y is equal to x square ka slope is 2x, right, Maulika? That you got?
Yes.
So we derived it, okay? So that means if we take this parabola y is equal to x square, and if we take a point here 1, 1. So at this point you will draw a tangent. So that tangent ka slope is 2 into x. And x ka value is how much? 1, right? That means this red color line is making an angle theta with the x-axis, where tan theta is equal to 2. You getting the meaning of this? Yeah. All clear with this? Great. Now, even though I said dy by dx, right, we could have used it for anything. For example, if I say dx by dt, so here you're comparing the position, let's say x is position and t is time. You can compare any quantity with any quantity. So if you compare position with time, we call this velocity, position by time. If you compare velocity with time, we call it acceleration. So even though I proved for y and x, you can actually use this for any type of variables. So that operator d by dx or dy dt compares anything with velocity with respect to time. That is the meaning of it. I can even have something like, dt by dx, where let's say t is temperature, x is position. Since you already know about slope, I explained you everything in terms of slope. Whereas in reality, you could have explained any quantity with anything. This is called as temperature gradient. Suppose if you have dw by dt, where w is work, small t is time, capital T is temperature. Rate of change of work is called power. So there are a lot of quantities in physics, right? You will get in terms of one quantity in terms of another. Clear? So it is not always about y and x, but you can actually compare anything with anything else. Any doubts so far? Anyone, anything that you're not clear, please ask. You can just unmute and ask, or if you're feeling shy, you can always type in the chat box here. Great. Now this quantity, right? D of dx f of x. So meaning the rate of change of f of x, since we are lazy people, we will simply write this as f dash x. If you put a dash on the top, meaning it's a first differential. So sometimes in the books you will see, right, f dash x correct. It simply means it's the first differential. Suppose if I say d of dx of d of dx f of x, means you're differentiating the same thing twice. This is written as d square by dx square f of x. This can be written as f double dash x. It's called double differential. Example, if you have d by dt, and if you have dx by dt, dx by dt is nothing but velocity. Rate of change of velocity is acceleration. So acceleration is nothing but d square x by dt square. The double differential of position is acceleration. So I can extend this even to an nth differential. Fnx. So if you see this symbol, it just means you're differentiating multiple times. That is just a symbol. Now what we will do, I will write down the main formulas, that we use in differentiation. We have especially, 3 types. So one second. Just let me check the attendance once. No, you guys still not come. Okay. So in this calculus, right, primarily we have 3 level of formulas. One is the basic formulas, and then we have some identities, and then we have a chain rule. So if you know these 3 things, the basic part is done, and then we'll see some applications also. So the first level of the formulas, right? Let's say if a function f of x, this is the differential of the function f of x. So if you have a constant, so if you differentiate a constant, so again, what is the meaning of, try to understand the meaning of dA by dx. How much is a changing with respect to x? Is a changing? No, right? A is a constant, so 0. So whenever you differentiate a constant, you get a 0. Example, if I have something like d by dx of number, let's say 23, 0. D by dx of some number like, let's say pi is a constant, 0. So if you differentiate a number, you get a 0. Second one, if you have a quantity x power n, the formula becomes d by dx of x power n is n into x power n minus 1. Everyone should note down this. Everyone should copy this down because we'll be doing problems on this better, Copy down this formulas on a separate paper or a notes, whatever it is. Example, if I differentiate d by dx of x cube, so here n is 3. The formula becomes 3 into x power 3 minus 1. I know some of you know this thing. This will look easy. Like I was telling you, right? Calculus is actually easy, but when you put it in physics, you will understand how nonsense it is. You seniors, even till today, right? They still struggle a lot, not because calculus is tough, but how do you implement it in physics is a different thing. We will see some problems. So, but make a note of this stuff. X power n is n into x power n minus 1. Suppose if I have something like d by dx of, let's say, root x. So that is x power half basically. So this can be written as half into x power half minus 1, which is half into x power minus half, which is 1 by 2 root x. We will not get into the question like how did we get this? We're not bothered. That maths people do that. Okay. Turn the page. Third, d by dx of sine x. So if we differentiate sin x, we get cos x. If you differentiate cos x, we get minus sin x. Tan x secant square x e power x. E power x gives you e power x only. This e, right, is called exponential. Just like pi, it is also a number whose value is 2.713. Comes a lot, many derivations. Ln x d by dx of ln x is 1 by x. This ln x is nothing but log to the base e x. So basically base e is called ln. Suppose if someone writes, ln 2, meaning it is log 2 to the base e. If I simply write log 2, meaning it is log 2 to the base 10. I hope Max they taught you logarithms. They'll teach you logs. So for now, just understand this thing. Logs they'll explain. These are the 7 main formulas. Note them down. So this is the first level, the basic differentiation formulas. So these 7 basic fundamental things you should know. There are some more also, a power x and all that, but physics may you'll never see them. Space may they will teach you sometimes, but completely irrelevant. Physics may never encounter them. So PACE booklet, what they did, right? They took the max ka content and they dumped it in physics ka booklet as basic calculus.
Sir, can you explain the thing in the bracket once again?
This thing?
Yes, sir.
In logs, right? There's something called ln and log. Ever heard about it? They'll teach you now. It's a separate chapter called logs. They will explain you in max. Let them do it and then we will see. There's something called ln x, so that way. Yeah, there is a reason when you solve it, you get the answer, Monica. But like I said, we are not interested in how these things came. And there is one more we have, a power x. Like I said, this you will never see in physics. But फिर भी ठीक है, put it down because sometimes people are weird, they ask. A power x. But the first 7 are the fundamental ones. Even that ln x also comes pretty rare, but it comes. A power x will never come in physics. So how did we get all these things? We are not interested. Next year, let max people teach you for 2.5 months. When they teach you calculus, you will think this is a joke. But we are going to need it. We can't wait till next year for them to teach. All clear with this?
Yes, sir.
Next thing, the second level, right? Identities. If you have dy dx of a constant into f of x, the constant comes out and you can just differentiate the function. Example, if someone says dy dx of 3x square, 3 is a constant, so it comes out. X square looks like x power n formula. That will be 3 into 2 into x power 2 minus 1, 6x. So if you have a constant, just push it outside and use that. Now you have to use the previous 7 formulas for this. dy dx of f of x plus or minus g of x. If you have 2 functions, addition or subtraction, you can simply split them. Differentiate f of x plus or minus differentiate g of x. Example, if you have something like dy dx of x cube plus sin x, you can simply write this thing as d of dx x cube plus differential of sin x. So you should know that 7 formulas which we wrote right now. If you don't know that, the second level you won't get it. So x cube will be 3 into x power 3 minus 1. Sin x will be cos x. So this will be 3x squared plus cos x. Have a look at this.
So in the second example, suppose you had three functions, would it still be the same?
Still valid. F of x plus g of x plus h of x plus keep any number of functions.
Okay, fine.
You can keep on just splitting it. We just did it for two simple ones.
So once again, could you go to the last slide?
Everyone note it down. Huh? We are going to do some problems on this, so you will need to see and practice.
Thank you, sir.
Copied. What is g? Just like f of x is function, right? We already used f now, so we are calling g of x. F is like function. G is also a function. Just like x, y, z are variables. F, G, H, these are functions. Like I said, right? Physics is short of symbols. You will see the same symbol in 5-6 chapters. So yeah. Clear. Third one. This is important. Comes a lot. F of x into g of x. We call it product rule. So in this, what you do, when you differentiate f of x, keep g of x outside. When you differentiate g of x, keep f of x outside. Example, let's say we have something like x square sin x. So you can choose any one as f of x and the other one as g of x. It doesn't matter. So according to this formula, sin x will be outside, and then you differentiate x square. Then x square will be outside, and then you differentiate sin x. So this will be sin x, and x square ka differential is 2x. This is x square, and sin x ka differential is cos x. So 2x sin x plus x square cos x. Check. Have a look at the example.
So basically you're treating one of the functions as a constant, right? And taking it.
Kind of. One is you're pushing it out, then you differentiate the other guy, and then add them both.
Yeah.
This is the third identity. Product rule comes a lot. This is the second level. There's one more. The third level is the final one. That we will do after some practice. Put it up. We'll do some problems of practice. We will get the hang of this. You need to get used to these differentiations. Copied. Going ahead. The fourth one is called division rule. D by dx of f of x by g of x. So in this, we have g of x, first differentiate f of x minus f of x differentiate g of x. Out of all, this is a complex one. Y g of x ka whole square. Example, let's say if I have d of dx tan x, this is nothing but d of dx sin x by cos x. So the numerator is f of x, the denominator is g of x. So if I substitute in the formula, cos x, differential of sin x, differential of cos x by g of x is cos x here, cos x ka whole square. Sin ka differential is how much? Cos x. Cos ka differential is how much? Minus sin x. Numerator becomes cos square x plus sin square x by cos square x. Sin square x plus cos square x is 1. 1 by cos x is secant square x. There. So basically the sin and cos are fundamental. From there you can derive all this tan, cot, everything. Check out the example. This is the fourth one, the division rule. This is all math. Physics set to come.
Sir,
Haan.
sir, d by dx tan x is equal to sec square x also, not directly. we can-
That only we derived it. Na? I'm showing you with the derivation, nothing much. That is an important result to remember, but I was just trying to show you how we can use this formula to derive it. These are the four identities, right? Constant into function, f of x plus or minus g of x, product rule, and the division rule. Let's see some problems for practice. And then we'll see some applications. And then, if time permits, we'll do chain rule, or else we can do it next class. All clear with this? Turning the page. Palaksh, Malika, clear, na?
Yes, sir.
Niranjan, Mehan? Perfect. Let's see. So I'll give you the functions. You have to find the differential and tell me. So f of x, x power 4, x power minus 3 by 2. Basically that way. Well, get them. Yeah, you can just solve it and I'll tell you the answers. Some of them are easy only. Get this right. Everyone should try. I'll show you the answers, then you can verify. Right, yeah. Solve. Everyone should give it a try. First was easy. I hope everyone got that. X power n ka type, so 4 into x cube. This is minus 3 by 2. X to the power of minus 3 by 2 minus 1. Minus 3 by 2 x to the power of 5 by 2. I brought it to the denominator. 1 by root x is nothing but x power minus half. So this is nothing but minus half, x power minus half minus 1. So minus 1 by 2 x power 3 by 2. This is nothing but cos x minus sin x. I hope all got the first 4. Anyone didn't get it, please ask me.
So,
Rehan.
so the third one I wrote minus 1 root of x raised to minus 2.
Minus 1
Root of x raised to minus 2.
x raised to minus. This way?
Yes, sir.
No, na. How can you do that?
So the third one we can do it by division rule too now.
No, that will be too long, na. Easily आ रहा है ना x power n का formula में. You can do division rule, but that will be too lengthy. Rehan, how did you get that? Wrong, है. See, n is minus half, na. The formula is n into x power n minus 1. So that will be minus half x power minus half minus 1, na. That is minus 3 by 2, right?
Yes, sir.
You won't get what you're saying. Check once. Got your mistake, no?
Yes, sir.
5, 6, 7, 8 people. How do you do sin square x? Sin x into sin x. Product rule. Yeah, Swastik, I think that's right. Right, Yasha. Hadrik. 6th one is right. Keep going. Others, everyone should try. So what is sin square x? D by dx of sin x into sin x. So you can call one of them as f of x, another is g of x. It doesn't matter. Later on, I'll teach you something called chain rule. You'll get the answer even faster. But for now, let's get used to it. The formula is what? F of x, differential of g of x, and differential of f of x. So sin x ka differential will be cos x. So sin x cos x plus sin x cos x. That will be 2 times sin x cos x. 2 sin x cos x is how much? Sin 2x, people. Hope you remember. Don't forget that. 2 sin a cos a is sin 2a. The same thing I can do for cos square x also. I'm writing everything now, but later on we'll skip all this and we will not be doing like this. Cos x will be minus sin x, so that will be minus 2 times sin x cos x. And that will be minus sin 2x. 1 by secant x, how will you do that?
The sec x into tan x.
Yeah. How do you do that?
1 by cos x.
Formula, no?
1 by cos x, no? We have to use f of x by g of x. Directly we don't know, right? We know actually sin and cos are fundamental. Everything else we have to derive. What if I give you something like cot x? Then what will you do?
Minus cosec.
Minus cosec square x.
Chalo, bad kar liya sab results then. So d by dx of secant x will be 1 by cos x. So this is f of x and this is g of x. So the formula will be cos x differential of 1 minus 1 differential of cos x by cos x ka whole square. This will be 0. Cos ka differential is minus sin x. This is cos square x. So sin by cos will become tan. Secant x tan x. Easy? Everyone got this? Eighth one will be x cube ka differential is 3x square. E power x is e power x. Ln x is 1 by x. You can directly write that. Please ask. Anyone confused with any particular part? Please ask me. This is like a pretty basic stuff. This you should know. And physics, they won't ask you like this. Let's see how they'll ask you. Any doubts? Anyone not clear with this 8 questions? Please ask. If you got all these 8, I think your basics are fine. Marika, Ritu, clear with this? 1 is a constant, na? If you differentiate a constant, it is 0. Ritu, you're there?
Yes, I'm there.
Your screen got stuck actually. Understood, right? All clear na so far? Ritu, clear na? Great.
Yes,
Abhinav,
yes.
Venkatesh, Niranjan, clear?
Yes.
Perfect. So let's see how they'll frame a question. We'll start with an easy one and then we'll take it up slowly. So we have a curve like this, which is given by y is equal to x cube. So this point is origin 0, 0. And we have a block here, mass m. So the acceleration of the block, now this we will see later on in work per energy. Is given by g sine theta where theta is the angle made by the tangent. Now, how did we get the g sine theta? Let's not worry about it. That's a different chapter. So the question is find the acceleration at 1, 1. So we have an incline y is equal to x cube. On that, when you keep a block, it will slide, and it is observed the acceleration is given by g sine theta. G is gravity. How did we get that? Don't worry about that. That is given. Where theta is the angle made by the tangent at the curve. Theta is the angle made by the tangent with x-axis. Basically, tan theta is slope. Find the acceleration at the point 1, 1. Just to show you how this question will look. There, we'll actually do questions of this sort, where we use a lot of integration and stuff. Differentiation will come. So this is a part of some big problem which you're going to encounter later on. Try. Like I said, the actual differentiation is easy. The headache is getting it in the applying, putting it in the terms. Try, I'll give you a minute. Anyone still confused with the question, please ask me. See, if the question is not clear, always ask. Don't hesitate. You're struggling on how to try, that's okay. Keep trying. You got time for that. Okay, someone got 3. Someone, Palaksh got 5 root 2. Mehan got 3. Aditya got 3 root 10. Not a single answer is matching with anyone. I don't think you'll get a good number, but I feel so. I don't think you'll get a good number. Aditya might be right. Try. You don't try. I'll give you a minute more.
So over here, what is y is equal to x cube?
That is the equation of the curve. The whole story वही था ना. उसका ही slope निकालना था. This is the path is there. This is the equation of that curve or equation of that incline. See, I'll help you with one. So you said the acceleration is g tan theta. So basically at this point, if you drop a tangent, this is angle theta, and you're saying this point is 1, 1. So slope of the tangent is dy by dx. That is the whole story. If you remember how we started the whole story, the slope of a tangent at a point is dy by dx, and y is how much here? X cube. So d by dx of x cube. This looks like x power n ka formula. So 3 into x power 2 minus 1, which is 3x square. The slope of a tangent is nothing but tan theta, which is given by 3 into x square. And here x is equal to 1. So we got tan theta is equal to 3. How to get sin theta from tan theta? I told you this many times. Listen again if you forgot. Tan theta is opposite side by adjacent side. So write it as 3 by 1. This will become root 10, Pythagoras theorem. So sin theta will be 3 by root 10. So it is given acceleration is g sin theta. G is 10 and sin theta is 3 by root 10. So this will be 3 root 10 meter per second square. Check. Aditya, you got it right. So basically at 1, 1, you have to differentiate, and jo bhi aayega, that is nothing but tan theta. Once you know tan theta, from there you can find sin theta, right? And substitute there. You're done. Please check. Is this clear, everyone? All got this? Same question. Let me put something more into this. Anyone confused with this or not clear, please ask. Rona, clear, na?
Yes, sir.
Malika, got this? Vidyut? So same question, if I frame this in another way, this is the first part of the question, okay? B part. Find the coordinates of the point where acceleration is 2 meter per second square. Reverse. First, I gave you the point and asked you acceleration. Abhi acceleration there on, I'm asking you the coordinates. This is what I was saying, it is always better to do one question in, different models we can do with one thing rather than doing 10 different questions. Same thing, I just reframed it another way. I gave you acceleration, find the coordinates. Numbers will be a little bad, but that's okay. Anyone confused with the question, please ask. Adrit, so far clear? Yeah. Niranjan, Abhinav, Swastika, clear hai na so far?
Yes, sir.
Yeah. Vidyut, your screen is blank, right? I can't see you.
Okay.
So the numbers coming very weird.
ठीक है ना, just get the equations and leave it. What are you getting? Quadratic, yeah?
No. It's something in root. Yeah,
something
root.
in root.
I just gave some random numbers. So basically, we have to go in the reverse. The acceleration is g sine theta, which is given as 2. So sine theta is 1 by 5. So sine theta is 1, hypotenuse is 5, and this is root 24. So indirectly, you gave me tan theta is 1 by root 24, isn't it?
Yes, sir.
And tan theta is nothing but what? dy by dx. So basically, at coordinates x comma y, tan theta is dy by dx, and we know y is equal to x cube. So this is nothing but 3x square. So you got 3x square is 1 by root 24. So x is equal to 1 by 3 root 24. That is
X root 6.
24. So 4 will come out now. 6 root 6 ka root again.
Yeah.
That is x.
Huh.
And y kya hoga? Y will be x cube, na? So 1 by 6 root 6 whole to the power of 3 by 2. Chalega, you can leave the answers like this.
Okay.
They won't ask you to simplify. Like I told you, we're not a max class. These are the coordinates. Check it out. You just do the reverse. Now I know the acceleration. From there you get sine theta, say tan theta, and then tan theta is dy by dx.
So this will. Okay, fine. Yeah.
Anyone confused with this, please ask. Are you getting how they will use this? So no one is actually interested in the differential part. The point is, how do you put that in physics? Let's see one more question like this. Turning the page. Next one. We have a parabolic mirror. Which is y is equal to 2x square. That is the equation of the parabolic mirror. Huh? Someone sent a horizontal light ray. So this is the light ray parallel to x-axis. After hitting the mirror, it becomes vertical. Now try to understand. This does not happen everywhere. Huh? Means if you hit somewhere here, you'll go like this. If you hit here, you'll go like this. No? So there is only some specific point on the mirror where this will happen. So this happens at this point here. Let's call it x comma y. Let's call it point P. Find x comma y. So this light ray actually becomes 90 degrees. So you have a parabolic mirror, y is equal to 2x square. The light ray comes horizontally, hits the mirror and becomes vertical. This does not happen at every point. There's a specific point on the mirror, on the parabola, only there the condition is satisfied. Find x comma y. So the previous question was Newton's laws of motion and calculus. This is light, ray optics and calculus. Applications will be like this. The differentiation part is actually easy. Putting it in physics is a headache. Try. Anyone confused with the question, please ask. You got a parabolic mirror. It's not a flat mirror. It's a curvy one. Y is equal to 2x square. A horizontal light ray hits a mirror at a point P, x comma y. And the light ray becomes vertically downward. Find the coordinates of P. Anyone confused with the question, please ask. I like the question here. So a horizontal light ray hits at P and becomes vertical. Okay, Niranjan got some answers, 1/4, 1/8. Adrit also got the same. Ronak, you also got the same X coordinate. 3 people got the answers. Try others. I'll give you a minute more. So basically we have to use this reflection ka concept here. See, at this point, if you draw a tangent, and if you draw a normal, now in a reflection, what happens? This angle and this angle are equal, right? Angle of incidence is equal to angle of reflection. If the total angle is 90, how much is this each angle? 45 and 45. Everyone agrees with this? If that is 45, then this angle is also 45. And if that is 45, parallel line, this is also 45. That means the slope of the tangent at point P is how much? Tan 45. Which is nothing but 1. And what is slope? Slope is dy by dx. And dy by dx is how much? 2 into differential of x square. So that will be 4x is equal to 1. X is equal to 1/4. And y is equal to 1/8. Just put that x back in the equation. Please check. So basically using reflection, you have to find the angle made by the tangent and then use calculus. So you can see what I did. I draw the normal. Normal and tangent are 90 degrees. Since angle of incidence is equal to angle of reflection and the total angle is 90, both should be 45, 45. So this is 45, this is 45. So the tangent is making an angle 45, slope is tan 45, and slope is dy by dx. So it is actually not a single pointer. All the points on this circle, it's a 3D shape. Any light ray hitting the circle will go down. It's actually a locus of circles. The entire thing is a locus, is a circle. If a light ray comes and hits a circle here, it goes down. But anyway, in our question, I clearly showed you from right hand side, so it is okay. Easy? All got this? Same question, I'll just extend it a bit. Anyone confused with anything, please ask. Perfect. Same question. Suppose let's say y is equal to 2x square. If a light ray comes and hits like this and bounces off like this, making an angle 120 degrees. Now can you find the coordinates of this point here? Let's call this point Q. Find coordinates of Q. So previous case it was 90, now it is 120. I just changed the question a bit. This is slightly more complex than the previous one. The numbers are different, big deal. Get it? Someone got some answers. So 3 by 4, 3 by 8. Okay. Let's see. We have one answer so far. Hmm. 1 by 4 root 3. Okay. Rehan got root 3 by 4. Palaksh got 1 by 4 root 3. We have two 1 by 4 root 3s and two root 3 by 4s. Someone is wrong. 1 by 4 root 3. We have three 1 by 4 root 3s. Maybe 1 by 4 root 3 looks right. Let's see. The story is exactly the same. First, draw the normal. Then draw the tangent. So somehow you have to get that angle. That is the whole question there. So this whole thing was 60. That means this was 30. I mean, this is also 30. The slope of the tangent is tan 30. Slope is nothing but dy by dx, which is tan 30 is 1 by root 3. So dy by dx is 4x. So x is 1 by 4 root 3. Check. And y will be, just square it and finish it off. That will be 2 by 16 into 3, 1 by 24. Interesting. Check. Right, Venkatesh. Ritu, you also got it right. Adrit, Mehan, Ronak. Yeah, most of you got it right. All clear? Let's see one more. Any doubts on this? Let's say we have a mirror. This is like a sine curve. Y is equal to sine x. The entire curve is a sine. So this is 0, 0. So light ray hits here and bounces off like this. And the angle between them is theta. This coordinates here are pi by 3, root 3 by 2. Find theta. This is the horizontal ray. The horizontal light ray hits the mirror and goes at some angle and makes theta with that. Find theta. Theta is the angle between the incident ray and the reflected. I hope you're seeing the thing what I was saying. The differentiation is actually easy. Sin x, x power n. But putting it there and figuring it out is a catch.
So then what's pi by 3 and root 3 by 2?
Coordinates na x, y. X and y axis na re.
Sir, but pi by 3 won't be degrees.
So what is pi by 3 is still a number, right? What is the problem?
So
Pi by 3 radians. Fine. That's okay. Na? Pi is always just a number. If there is something in pi by 3, leave it in pi by 3 only. That's okay. Pi by 3 is like 60 degrees. Try. If you get something like tan inverse, 3, like you can leave the answer in that form. You won't get, if you don't get a proper angle, that's okay. Why did this thing get erased? Try. I'll give you a minute more. Tan inverse half. Okay. Niranjan, Venkatesh. Okay. You have two answers, people. Niranjan and Venkatesh both got tan inverse half. Looks right. Maybe right. Others. Aditya, Ronak. Any answers? Ritu, Arjun. Okay. Ronak also got tan inverse half. See. So basically, what we do, let's draw a normal like this. This is your normal. This is your tangent. So this is theta. And we know this whole thing is 90. And this will be 90 minus theta. If that is 90 minus theta, this is wait, I already used theta. Let me use something else. I'll do one thing. Let's call this alpha, because theta we are using it for. So if that is theta, this is 90 minus theta. So basically this angle will be 90 minus theta and this angle will be 90 minus theta. So basically alpha is 180 minus 2 theta. I hope that was clear. You're done. Agar theta aa gaya, you're done. So what is tan theta there? Tan theta is nothing but slope. Slope is nothing but dv by dx. And here y is nothing but sin x. So this is nothing but cos x. And x ka value is how much? Pi by 3. So this will be cos 60. So tan theta is equal to half. So you can write theta is equal to tan inverse half. So alpha will be 180 minus 2 times tan inverse half. You can leave the answer like this. No need to simplify it further. But write in terms of pi. Pi minus 2 into tan inverse half. That is better.
So when nothing is
Hmm.
given, we can assume it's like a unit circle or something.
It's not a circle, right? It's a sin x, no? It's a
Yeah,
sin
I
curve.
know, but like for the coordinates, like cos x, you
Nah.
directly took as 6, this thing.
Because x coordinate is given, x is pi by 3. I just substituted that here.
So, but how do we know that's not a number and that's like a value? Like that could be this thing also, na 180 by. Acha, no, I got it.
Cos 60, no? 180 by 3.
Correct, yeah.
Check. See where it went wrong, everyone. Tan inverse of, I think, I don't know what you guys did exactly, but see why you got tan inverse of. 3 of you got the tan inverse of. Adrit got it right though. All clear with this? Ha, Ritu? Clear, no?
Sir, you wrote alpha equal to 180 minus 2 theta. So,
Ha,
like,
because this whole angle is alpha, na?
oh, right, yes.
So I took this whole angle as alpha. I just changed it to, because theta we are using it, I changed theta there. All clear with this? Easy? Perfect. Let's see one more and then we'll go for the chain rule. Now, just to give you a little brief about this. Let's say we have x is equal to t cube by 3 minus 3t square by 2 plus 2t plus 1. Here x is position, t is time, v is dx by dt. So every time, you need not differentiate with x, you can differentiate with t also. This is nothing but velocity. So the position is changing with time like this function, and v is velocity. So find velocity as function of time t. That is one question. Find time when velocity is 0. Find distance traveled by the particle in 4 seconds. So first part is easy. सिर्फ इसको differentiate करना था. So be careful. Every time you won't get dy by dx. I can ask you in terms of time. I can ask you in terms of x. I can differentiate anything with anything. So basically, y का place में x is there, x का place में t is there. And if someone is still confused, I'll just give an example. If I say d by dt of, let's say, t cube minus t. So this is simply t cube by dt minus dt by dt. So basically that looks like x power n. So 3 into t square minus 1. I hope you're getting xt. It is simply variables. Max doesn't care what is x and t. It is you and I who call it x and t. Get these 3 questions. The third one is a good one. The third one will be a proper mains level question. So the position of a particle, x coordinate of a particle is given by t cube by 3, 3t square by 2 plus 2t plus 1. X is position, t is time, velocity is dx by dt. Find velocity as function of time t. We simply write it as v of t. Try. Everyone give it a try. T square minus t. Nearest Swastika, that is wrong. Check. Venkatesh, you got that right. First part, people. T cube by 3 minus 3t square by 2 plus 2 plus 1. T square minus 3t plus 2, na, Venkatesh? Aditya? You kept equal to 2. That is plus, na? Yeah, I think maybe instead of plus, you kept an equal to sign. Got it. Okay, someone times also you got. Distance traveled, huh? That is the actual one. Ronak, you're right. Equation, you got it. Get the rest. C is an actual question. Huh? First 1 and 2 are just there. Dummy questions, those are. And you need to do 1 and 2 before doing 3 anyways. Get the third one. 2 minutes. The first one, I'll just show you the first one for people in case someone is struggling. So velocity is dx by dt. So just differentiate the whole stuff. 1 by 3 dy dt t cube. You should get used to this slowly. I'll send you a small sheet for this practice. D square plus 2 dt by dt. And 1 is a constant. You should see and write the answer next time. T cube is 3t square, so that will be t square. This will be minus 3t plus 2, that is 0. Please check. 24. You got such a beautiful answer, right? Venkatesh, that's not the answer.
Sir, can you show the third question?
Distance traveled in 4 seconds.
Sir, we need both the first and second question for third.
Yeah. 24 nahi hai answer. Most people are getting 24. You're forgetting something. Distance and displacement are not same. Think about that. I'll give you a minute more.
So can you just show the first answer?
Yeah, hai na answer. So B, velocity, you got t cube, t square, minus 3t plus 2. The question is find the time when velocity is 0. T is equal to 1 and t is equal to 2. Check, these are the first 2 questions ka answers. Anyone didn't get these 2, please ask. If you're confused, I'll show you. But get them cleared. I'm just concerned, like I changed the symbol, so you might get confused. That's what I'm worried. But in case you're confused, ask me, don't hesitate. You got it? Great. Find the distance traveled. That's the third question. Find the distance traveled in 4 seconds. Anyone confused with the A and B part, please ask.
Sir, can you like explain the A and B part just one more time?
I just differentiated. Na? T cube ka differential is how much? 3t square. Right, Ritu?
Yes, sir.
So that 3 and 3 will cancel, no? So you'll
Oh,
get a t
right.
square left out. I
Yes,
simplified
sir.
it actually. T square ka
Okay.
differential 2t, na? That 2 and this 2 will cancel. Yeah, basically I skipped a step. Aditya got 16 by 3. Could be the answer. I don't know the answer. Let's see, people, what is actually happening. I'll tell you. See, the catch in the question, na, x is equal to t cube by 3 minus 3t square by 2 plus 2t plus 1. At t0, where are you? If you put t0, where are you? X is not 0. At t0, x is equal to 1. Means the particle is starting here. At t is equal to 1, where are you? So let's see the points you'll understand. T0, x is equal to 1. At t1, x is equal to how much? Substitute the values there. 1 by 3 minus 3 by 2 plus 2 plus 1. 3 by 2 plus 1 by 3, 11 by 6. At t is equal to 2, where are you? Eight by 3 minus 6 plus 4 plus 1. 5 by 3. At t is equal to 4, where are you? I should have given 3 seconds actually, but okay. This became big. 64 by 3 minus 24 plus 8 plus 1. 64 by 3 minus 15. 15, 345, 19 by 3. All got this? These coordinates are clear, everyone? So I found where is the particle at 0, 1, 2. Why 1 and 2? That is the time when the particle stopped. And 19 by 3 at 4 seconds. Now see, if I try to put them on a graph, you will see something. At t0, you are at x is equal to 1. You started here. At t is equal to 1, you have gone to x is equal to 11 by 6. Agreed. That is okay. That is close to 2, but it is not 2. Then something happened. T is equal to 2. You're suddenly at 5 by 3. Means what? The particle has gone ahead and took a turn. Na? It came back again. Are you getting it? The coordinate has decreased. 5 by 3 is how much? 1.66. At t is equal to 4, where are you? 19 by 3. So suddenly you have again gone somewhere here.
So the particle turns around only when it becomes zero, na, but
When the velocity becomes 0, na? So it has
Yeah.
gone like this. So basically, at this point, right, velocity is 0. At this point, velocity is 0. So whenever the velocity is becoming 0, it is becoming 0 to take a turn. Are you getting how is the particle going? It is going front, back, and then front. How do you know this is happening? Because you got 2 times the velocity is 0. Think about it. Whenever you're going straight and if you want to go back, for a moment, you have to stop for a moment and come back. And how do you know it is coming back? Look at the coordinates. You're at 1, then you're at 11 by 6, then you're at 5 by 3. Means you went front and came back. And then 19 by 3 means again you went ahead. Just try to understand this once. So whenever you stop, you're actually taking a turn back. And how do you know that? Look at the coordinates. 11 by 6 is approximately 2. 5 by 3 is 1.66. You have gone from 1 to 2 and 2 to 1.66. Obviously, you came back. And then you gone to 19 by 3. 19 by 3 is almost 6.33. You have gone ahead again. This is a pretty good one, right? Even at a mains level, this is a little moderate to tough. Please check this out. Anyone didn't understand this part, please ask me. Once you got this, now what is the distance traveled? Distance is the total length of the path. What most of you did, right? You took the initial position, you took the final position, and you subtracted them, I suppose. If you do that, you'll get displacement. So distance traveled will be 11 by 6 minus 1, the first section, plus 11 by 6 minus 5 by 3, the second section, plus 19 by 3 minus 5 by 3, the third section. So each section ka length you have to calculate and add. How much is this coming out to be? 11 by 6 minus 1 is 5 by 6. That is 11 by 6 minus 5 by 3. Multiply 2 and 2, 10 by 6, 1 by 6, 14 by 3. 14 by 3 plus 1, 17 by 3 meters. Right? Please check your answers. Go more. Message now. Please have a look at this. It's a pretty good problem. Don't worry about it. Again, we will do this kind of problems in kinematics. They will be a little more complex ones, but this is how they'll ask questions in the exam. They won't ask you to differentiate the function. No one is interested in that. All clear with this, Ritu? Malika? Malika? Sure? Yes, no, something.
Sir, how you got 17 by 3? Sorry.
How did you get 17 by 3? Malika, you have to say something properly.
Yes,
I'm not
that
understanding.
How did you get 17 by 3?
I just added this thing now. 5 by 6 plus 1 by 6 is 1. 1 plus 14 by 3.
Okay, sir. No, but like, won't we add the turnings? means when it turns, don't we add that, or is it
No, no,
negligible?
actually it is going like this, it's on the same line, no? For you to understand, I'm drawing like this,
Okay.
right? It is actually going in a straight line. Then on the same line, you come back and then again you go front.
Okay.
Got it? So I know what you're saying. You're saying this part, no?
Yes, sir.
And that is not there. That is just for understanding. I draw it that way. But rest of the question was clear, right?
Yes. Sir.
Then fine. Ritu, sure, right? Palaksh, Abhinav,
So
But I have a doubt.
ask Swastika, bolo na.
So we have to find the distance, not the displacement. So
Right.
do we have? Yes.
Displacement would be easy, right? Displacement is final minus initial. That would be how much? 19 by 3 minus 1, no? That is 16 by 3. That is displacement. But what is the distance traveled? The length of the path, right? You have to take all the distance, whether you go front or back. Right, Swastika?
So can you explain this distance part again? Like how did you get
See
it
now.
11 by 6 minus 1?
Which one? See, for example, let's say you go 10 meters front and you come back 10 meters back. What is the distance traveled?
20 meters.
Displacement?
10. Sorry, 0.
0.
10.
So, ho gaya na? Displacement is simply initial to final. Na? What is distance? Distance is this path, and this path. Na?
Yes.
So you have to add all that, right? So how much is this? 11 by 6 minus 1.
Okay, yes, sir.
How much is this? 11 by 6 minus 5 by 3. How much is this?
Yes.
19 by 3 minus 5 by 3.
Okay, yes, sir. Yes, now.
Sure?
Yes,
Hmm.
sir.
Anyone else confused? Please ask. It's a good one.
So if there was a plus sign instead of the minus sign directly, you could have calculated displacement, right?
Where? Which one you're saying?
In the equation, x equal to between
If
the.
you had got a plus sign, it wouldn't have taken a turn only, no? It's just going in a line.
So
Actually.
we could have directly calculated.
Then we could have done
displacement.
actually. Life would have been easy.
Uh-huh.
All sure with this? Mehan, clear, na? Great. Last one for that day. Chain rule we do next class, more applications on that. So we got a pole here. We got a bulb. The height of this pole is 6 meters. And we have a person here, 2 meters tall. The person is walking with a speed of 1 meter per second. So what will happen? When the light falls here, this thing, right, is a shadow. P is the shadow of the head. I'm sure you must have seen this. When you're walking on a road, you must have seen your shadow on the road, right? So when you're walking, your shadow also goes forward. So this entire dark thing is the shadow, and the P is your head ka shadow. So the man walks away from a pole with a speed of 1 meter per second. Right? Find the speed of point P, where P is the head of the shadow, and find the rate of change of length of shadow. Means at what rate is the shadow length is increasing. So every time the man walks with 1 meter per second, at what rate is the shadow increasing? Example, let's say initially shadow is 2 meters. Next second it becomes 2.2 meters, meaning the shadow is increasing 0.2 meters per second. That is what I'm asking. At what rate is the shadow length is increasing?
But
The
sir,
distance.
won't these two things be the same?
Nah.
Speed of
Prove it, na. Prove it, na.
the length the shadow is increasing, the physical it will be the same.
Nah, it is not same. Nothing is given. This distance is not given. We don't know how far is the man.
Sir, the angle. Not even the angle.
Nothing is given. This is the only data you have. Light pole is 6 meters, man is 2 meters. He's working with 2 meters per second, the shadow falls on the ground. The entire dark line is a shadow. Find the speed of P. P is that head cast shadow, and the rate of change of length of shadow. Like I said, right? If you see in this question, there are no variables to differentiate, nothing is there. So you have to convert a verbal question into calculus question. Actually, differentiation, there'll be very little less in physics. The headache is always this. How do you convert a verbal problem? If you observe here, right, all these questions that I taught you, 1, 2, 3, 4, there is no equations anywhere. You have to make an equation and then differentiate somehow. 5 is still okay, I gave an equation. This is the reason why people find calculus is a little on a higher side, but you'll get used to it. Aditya got half. What is half? The speed of point P or shadow ka rate? There are two questions here. Okay, rate of shadow. Fine, that is right. Try. Others, give it a try. Just give it a try. I'll get some water and come. Okay, Adrit also got rate of shadow is half. Ronak also got half. Okay, let's see. I'll help you out. See, question is not tough. Don't worry if you didn't get it. The problem is getting that variables is little different. You should actually assume variables and do all that. That's the whole point, na? That's the reason I'm teaching you. You'll get the use of it. Actually, physics, this is how you should learn calculus. But one thing that I see, right, people are more obsessed about actually the equations. Big differentiation. We are not a max class. Max may anyway they will do that. Physics may you're more interested in the situations. How do you bring calculus into the situations? This is the kind of problems you'll see in physics. So let's say this is x. So if I take this point as 0, man ka coordinates are x, 0. So just now we said, right, what is dx by dt? Velocity. What is x here? X is the x coordinate of man. X is x coordinate of man. So if you differentiate x coordinate of man, whose velocity will you get? You'll get velocity of man, na? Does everyone agree with that? If you differentiate the x coordinate of the man, you will get the velocity of the man, which is nothing but 1 meter per second, which is given. Then from here, if you drop the shadow, let the length of the shadow be y. That means this point P ka coordinates are y, 0. So here y is the x coordinate of the P. So if I differentiate, not y, x plus y. So if I differentiate x plus y by dt, then I should get speed of P. So whoever coordinates you differentiate, you will get the speed of that particular point. So now we need to get the relation between x and y. Let this angle be theta. This is 2 meter, this is 6 meter. Tan theta for the full triangle 6 by x plus y. For the small triangle 2 by y. That will be 3y cross multiply into x plus y. We get y is equal to x by 2. Please check. What is y here? Y is the length of the shadow. Any doubts, please ask me. So the main thing, right? You have to assume the variables. Okay, this is this, this is this, this is like that. You should get used to these kind of things. And then what you do, if you can substitute here d by dt x plus y, that is nothing but x plus x by 2. This is the VP. So this will be 3 by 2 dx by dt. But what is dx by dt? 1. That means the point P is going with a speed of 1.5 meter per second. And what is dy by dt? Dy by dt is nothing but rate of change of length of shadow. Because y is the length of the shadow. So if you differentiate y, you are getting at what rate the shadow length is changing, which is nothing but half of dx by dt. Dx by dt is 1, which is half meter per second. Means every second your shadow is stretching by half meter. So look at the scenario. Every second your shadow is stretching by half meter. Man is walking 1 meter. So total is 3 by 2 meters. Na? Is that making sense? That's why your head is going faster than you. The shadow is stretching by half meter and you're going forward by 1 meter. Your head is going 3 by 2 meters. Please look at the steps here. If you see there is no calculus here, dx by dt, dx by dt, it is just one simple differential. Look at step by step, each and everything. Anything you're not convinced or not clear, please ask. The calculus is actually easy. The applications are a headache because you have to create variables and you have to figure out what each variable means. If x is the x coordinate of the man, the rate of x coordinate will give you the velocity of the man. If x plus y is the coordinate of the point P, then uska differential will give you speed of point P. Y is the length of the shadow, so dy by dt will give you rate of change of length of the shadow. And y is x by 2. We proved that from geometry. Please check. Make sure to go through these things. I'll make a small sheet, 5-6 questions of similar models. The next class when we meet, right, we will do something called a chain rule. That is little more useful for solving more complicated differentials. And then we will see applications of trigonometry. Applications of this differentiation. We will see few more variations of this, velocities, accelerations and stuff. And then we have something called maxima, minima, what happens when you differentiate a vector. So we will combine vectors and calculus. So differentiating a vector has a different meaning. So we will see all that stuff. So there are some things, and then we have maximum, minimum, a lot of stuff. Quite useful. Literally, these things will pop up at multiple places. I think next class and that after class applications will be more interesting. So differentiation will take little time, 4 classes total, and then calculus we will do. After that, we'll start off with kinematics. Okay, so with this, we'll wrap up for the day. So the sample test is online. Everyone can just register, give the sample test and see how the site looks.